Welcome back. This is the part 2 of the topic on oxidation and reduction. Please, if you're here to watch part 1, make sure you do before moving ahead with this class. So, although nothing much is missed, just go and check it out before you move on with this class. So, we'll be looking at oxidation and reduction proper. So, please, let's focus on oxidation and reduction. A whole lot of times students are given different types of equation and ask them to determine, is this reaction an oxidation reduction reaction, or what form of reaction do you think this reaction is? And in some other scenarios, students are given a type of equation and asked, for example, let's say I give you the H2S reacting with chlorine gas to give me hydrogen chloride plus sulfur. In this scenario, with what I have in this equation, is this a type of oxidation reduction reaction? Let's check it out. What is the oxidation? Which one is undergoing oxidation? Which one is undergoing reduction? That is what we're about to check out in this class. If I give you this reaction, sodium hydroxide reacting with HCl to give me NaCl plus H2O. Generally, we all know that this is a neutralization reaction, but it's not every reaction that you see that you just assume that this is a type of reaction. You can confirm it what type of reaction this is. So looking at these two equations, which one is a redox reaction and how did you know that this is a redox reaction? So that's what we're about to talk about in this class. Now, but before we move to that level, let's look at what we call oxidation and reduction. There are different definitions we give for oxidation and reduction. One, oxidation is the addition of oxygen to a species. Oxidation is the addition of oxygen to a substance, while reduction is the removal of oxygen from a substance. For example, if I have this Zn plus CuO to give ZnO plus Cu. Now, I need you to note something. Every time you are asked a question on which of the following is undergoing oxidation, which of the following is undergoing reduction, please do not pick your answer from here. This is not going to, or any of this is not going to be your answer. None of this will be your answer, but one of this will be your answer. Which means, let's say this is my option A, option B, option C, option D. Automatically, option C and D, they are out. So my answer will be between A and B. So please do not go to the product side to pick out your answer when you ask that which one is undergoing oxidation or which one is undergoing reduction. I hope that is clear. Now let's go back to this equation. I said oxidation is defined as addition of oxygen to a substance, while reduction is the removal of oxygen from a substance. Looking at this equation, where did we remove oxygen? We removed oxygen from CuO. That means this guy is undergoing reduction. We added oxygen to this guy. That means this guy is undergoing oxidation. So your answer would be zinc. So zinc is undergoing oxidation because we have added oxygen to zinc. Another definition is that oxidation is defined as removal of hydrogen from a substance. Oxidation is defined as the removal of hydrogen from a substance, while reduction is the addition of hydrogen to a substance. Let's look at this equation, for example. Where did we remove hydrogen? I told you, don't forget not to pick your answer here. Which one is undergoing oxidation in this case? If you look at this, we are removing hydrogen from H2S and we're adding the hydrogen to chlorine. So which means that removal of hydrogen and adding it to chlorine, removing hydrogen for a means H2S is undergoing oxidation, while chlorine is undergoing reduction. I hope that is clear. We removed hydrogen from hydrogen sulfide, we added it to the chlorine gas, we produced hydrogen chloride and yellow sulfur. Now, from what we have in this case, this one is undergoing oxidation. Now, another definition for oxidation is that oxidation is defined as the addition of a highly electronegative element, while reduction is the removal of a highly electronegative element. So let's check this out. From what we have in this equation, we all know that chlorine is more electronegative than sulfur, right? So when we are adding chlorine to this guy, that means we are adding a highly electronegative element to this guy. Do you understand that? So addition of this to this guy makes this one undergo oxidation. So you are removing this one from this guy, although from the definition, when you add a highly electronegative element, you remove the less electronegative element. So addition of a highly electronegative element to a substance is called oxidation. So why this one is undergoing reduction? I don't know if you understand that. So now, when you're talking about oxidation again, oxidation is also defined as the removal of a highly electropositive element, while reduction is the addition of a highly electropositive element. So they are like opposite. So if you're looking at this, in H2S, sulfur is more electropositive than chlorine, just like what we said here. But chlorine is more electronegative. So we are removing sulfur from here. That is why this one is undergoing oxidation. So removal of a highly electropositive element is oxidation. I hope you understand that. So we are removing this sulfur from H2S. Then H2S is undergoing oxidation. So do not get to bother yourself about this. What is so important now are the two things I will talk about in the next two slides. So when you're talking about oxidation generally, there are two major things to focus on. One, oxidation number. So we're focusing on oxidation number and electrons. So when you know oxidation number and electrons, then I think all your problems on oxidation reductions are solved. So let's look at it. What is oxidation? Oxidation is defined as loss of electron. You know, when an element loses electron, what happens to its oxidation number? Its oxidation number will increase. Like, for example, sodium has 2,8,1. It's going to lose 1 electron to form Na+, giving us 2,8 plus 1 electron. Now, looking at this equation, 1 electron has been removed from sodium here to form 2,8. And this Na goes from Na0 to Na+. The oxidation number has increased from 0 to +1. So if you lose electron, oxidation number increases. For example, if I write Al3+, how many electron has been lost by this guy? Very good. It has lost 3 electrons. That is why it is carrying 3+. Do you understand that? So when you're talking about oxidation, oxidation is defined as loss of electron, meaning that sodium has undergone oxidation in this case, while reduction is the gain of electron. Let me use an equation to tell more about this. You can see now that this has undergone oxidation. So let's look at this. Zinc plus Cu2 plus. Cu2 plus comes from a salt like CuSO4 2-, but SO4 2- is known as a spectator ion in this equation, so we will not be talking about it much. So looking at this equation, zinc reacting with copper 2 plus will give us Zn2 plus Cu solid. From this equation, what happened? Zinc went from Zn to Zn2 plus. So what does that tell you? This means that zinc has lost 2 electrons, Abi. So zinc losing 2 electrons from this to this, meaning that zinc is undergoing oxidation. So the oxidation state, oxidation number of zinc has increased from 0 to +2. Why that of copper has gone from +2 to 0? What happened to copper? Copper actually gained the 2 electrons that was lost by zinc to give us copper solid. So this one is going from +2 to 0, while this one is going from 0 to +2. So you will see that the one losing electron has an increase in oxidation number, while the one gaining electron has a decrease in oxidation number. So generally, oxidation is defined as an increase in oxidation number, and it is also defined as loss of electron. You always remember this word, oil rig. Oil rig means that oxidation is loss of electron, then the rig means that reduction is gain of electron. So which one is gaining electron in this equation? Copper 2 plus. Do you understand that? So Cu2 plus is gaining electron, zinc is losing electron. So this one gaining electron is undergoing reduction, while the one losing the electron is undergoing oxidation. So that is what you talk about, and these two are very, very important in determining many things. In the next class, which is the part 3, we don't want the class to be too bulky. So in the next class, which is the part 3, we'll be talking about oxidation number, and this oxidation number will help us to determine many things. All the stories I've been saying since morning, when you look at an equation, can you tell if it is an oxidation reduction equation? All these things we'll be learning them in the next class. So please make sure you watch the part 3 of this class so that you understand this topic fully well. I will drop some questions on what I've said so far today, just for you to look at some clues. But you will now look at it that it's easier to determine. If I give you any form of equation, it's actually very, very easy to determine which one is undergoing oxidation or reduction when you understand oxidation number. So solve the following questions. Leave questions in the comment section below. If you are just joining us, this is Primax Privacy. Try and subscribe to the YouTube channel so that you continue to get more updates on our academic activities. God bless you.